I think 2 or 3 sessions, listens with listen. Yesterday, I think you have been already gone with this all our IPA PCA.
I think the host muted everyone.
Okay. Sir, is it any problem?
Sir, please kindly mute yourself while some others are talking because of the disturbance.
Yeah. Yeah. Is Ram Sir?
You should open the audio.
Okay. Is it okay?
Yeah, it's audible, sir.
Okay. Dr. Bhavani Garu, yourself and your management really has been really we're all appreciating you regarding your hard works. Really, you have brought all this really this rural to global. You made it really great, because today I think a surprise, because when you have sent me all these links now, really Susuta, the old friend of mine, and he's from Seoul, and other friends from our Ramesh Raj Garu from Viper, and another friends from the other abroad. Really great. Now it has made it the international webinar. And today morning I spoke to our IPA president, Stephen Nanagar also. He has appreciated your management and your personal efforts. Anyhow, this kind of Arogya Setu, really the subject of the coining, the time of the coining words really. And another thing I want to share you, the Telangana Pharmacy Management's recently we association we have approached our Honorable Health Minister and other Director of Health. All these totally 30 pharmacy really who are running the PharmD college, Hyderabad and near in Hyderabad. We have given the more than 170 to 180 PharmD students, interns who are studying 6th year. We have given the names and they have approved it. Within 15 days, we are going to take really the social distancing mode. We are going to activate the program. We'll tell you later. But our Dr. Ramesh Rajgar also is going to participate, and Sultanudum College and our college and Malaradi College. All this total 30 college students are participating in the different kind of social servicing activity in the name of the social distancing. How to behave the people under the social distancing, how to make them, and this kind of all these hygienic conditions, how to move this, we are going to do. Anyhow, with this, I should not extend this because this is the academic lecture now. My heartful congratulations behalf of from the Telangana Pharmacy College Management to you, all the Koringa College Management, all other staff members, and today's speakers also. Really, all the global and national speakers are very well. We appreciate you. We'll continue our support, sir, from our management association, from Indian College Management Association also. We'll support you. We'll keep on, and please protect the people and educate all the pharmacy students, and make to highlight the pharmacy education in this COVID scenario, sir. Thank you very much. Thanks for participating. Thank you, Andy. Carry on.
Thank you, sir, for gracing the occasion. Thank you very much, sir. Okay, sir, congrats, sir. Shall we start?
Okay. Thank you, Ramdas Garu, and thank you, the speakers. It is a great pleasure today webinar conducting Arogya Raksha Pharma Series 2. Today's speakers are very well known to the national and global level. It is our happy moments to share with you in this webinar, and our students will be benefited through your messages. We are very thankful to all the speakers, sir, and welcome to the webinar, sir. Proceed, Amma.
Okay, sir. Good afternoon to everyone. Welcome to Arogya Rakshak Pharma series, as we are conducting an international webinar, especially with the platform of interaction with the expert pool. So now you can meet people coming from the different countries. It's very honor to see all the grateful persons here. Thank you, sir. Now I would like to introduce one after the other speaker. Okay, Sheena, continue.
Okay, madam. Good afternoon, everyone. A very warm welcome to Arogya Rakshak Pharma Series 2, organized by Koringa College of Pharmacy. Today, we have with us four eminent personalities from pharmacology to discuss their views on drug repurposing. I take the honor of introducing our today's speakers. Dr. Srinivas Nammi is a faculty member in pharmacology and academic course advisor at the School of Science and Health, Western Sydney University, Australia. He has a doctorate in pharmaceutical sciences, specializing in pharmacology. Before joining the Western Sydney University, he worked at the Faculty of Pharmacy, University of Sydney. After gaining years of postdoctoral experience as DAD Fellow at the University of Tübingen, Germany, and as University Postdoctoral Fellow at the University of Manitoba, Canada. He has also worked as an industrial pharmacologist, a position in which he was instrumental establishing a new pharmacological research laboratory. He has a distinct track record in Ayurvedic and Western herbal medicine research for over 20 years and has made significant contributions to both basic and applied research related to drug discovery, biological evaluation, and mechanistic studies with a special focus on metabolic disorders. He has attracted competitive research funds from national and international educational as well as institutional bodies. He has won international patent and published over 80 scientific papers, 10 editorials, and 3 book chapters. He has also contributed over 40 research abstracts published in the proceedings of national and international conferences, symposia, and seminars. His research has been cited so far in over 3,000 publications with an H index of 28. He has significant professional outreach through his contributions in academic and scholarly activities. He is serving as secretary for the Australian DAD Alumni Association. He is frequently invited to talk and chair at international conferences and to adjudicate PhD theses from Australian and overseas universities. He sits on the editorial and review boards of a number of biomedical journals, including BMC Complementary and Alternative Medicine and Evidence Based Complementary and Alternative Medicine. He is an international expert reviewer of a number of national and international research grant bodies. He is also frequently invited to guest edit journal special issues and to contribute to book chapter. He has been awarded a number of fellowships and awards, including the prestigious DAD Fellowship, Germany, SESQUI Postdoctoral Fellowship, Australia, and CSIR Senior Research Fellowship, India. In 2018, he has been awarded for the Excellence in Research Award by the School of Science and Health, West Sydney University, for his contributions in research. A very warm welcome you to, sir. Now, I request our today's next speaker, Dr. Koppula Shushruta, Associate Professor, Division of Life Sciences, College of Biomedical and Health Sciences, South Korea. Dr. Shushruta Koppula received his master's and PhD in pharmaceutical sciences, majored in pharmacology at University College of Pharmaceutical Sciences, Andhra University, Visakhapatnam, India. After completion of his PhD, he was appointed as a postdoctoral research at the College of Medicine, Neuroscience Research Institute, Seoul, National University, Seoul, South Korea. He is a recipient for Korea Scientific and Engineering Fellowship on highly competitive basis from Seoul National University. Later, since 2009, he was appointed as a faculty at College of Integrated Biosciences, Pharmacology and Biotechnology Department at Konkuk University, South Korea, which is one of the top 10 universities in South Korea. Dr. Koppula has published more than 85 scientific papers in peer-reviewed international journals. He received 3 patents in drug discovery for Parkinson's disease and published 4 book chapters in various areas of interest. He also presented his work in various national and international scientific meetings. Dr. Coppola is an active investigator on several projects jointly with Korean collaborators. He received Teaching Excellence Award for the year 2018, and he is the only Indian so far in Korean universities. His current research interest lies in the area of neurodegenerative and neuroinflammatory diseases, natural products and drug discovery, stress and age-related disorders, endocrinology and male sexual dysfunctions. His minor research is focused on role of inflammation in brain and liver disorders, pharmacological screening of natural products in treatment of hepatic disorders. Dr. Coppola resides with his family in South Korea. In his free time, he enjoys playing golf, swimming, and explores Korean diverse tradition, food, and culture. A very warm welcome to you, sir. Now, I introduce our today's next speaker, Dr. K. Ishwar Kumar, Associate Professor, AU College of Pharmaceutical Sciences, Andhra University. Dr. K. Ishwar Kumar has completed his B Pharm from Andhra University in 1995. Sir has completed his M Pharm from Andhra University in 1997. He has completed his PhD from Andhra University in 2006, and his thesis was awarded as the best thesis. Sir has a total of 22 years of experience in both teaching as well as research. Sir has guided till now 27 PhD candidates, and 4 of them were under adjudication. Sir has guided 44 MPharm projects. Sir has a total of 149 publications. Out of them, 31 were national and 115 were international. Sir has handled many projects. He has handled 2 projects by AICTE, 1 project by UGC, which is worth the total cost of 50 lakhs. He has completed the projects by MHIRT, NIH, as well as USA. Sir is having 2 published patents as well as 2 examination patents. Sir has attended international conferences like Experimental Biology Meeting in Washington, D.C., USA, as well as Boston, USA. Sir served as a visiting scientist in Department of Physiology, University of Malaya, Kuala Lumpur, Malaysia. Sir has many positions. He was elected as Vice President, Association of Pharmaceutical Teachers of India, AP State Branch, for a tenure of 2 times, that is from 2000 to 2017. Sir served as Joint Secretary, Indian Pharmaceutical Association, Visakhapatnam Local Branch. Sir also served as co-convener, Andhra University Research Forum, and presently sir is serving as an warden, AU Engineering Hostels, Andhra University. Apart from that, sir has received many awards. He has gained best paper awards in his presentations. He have received Professor Desarazu Venkatrao Endowment Prize for the best PhD thesis in pharmaceutical sciences for the year 2006 by Andhra University, Visakhapatnam. He have received Best Researcher Award 2017 by Andhra University, Visakhapatnam. He have received Best Teaching Pharmacist Award 2017 by Seemandhra Drug Dealers Association and AP Private College Management Association. He received Professor P.P. Suryakumari Award for the best paper published in international journals in the Golden Jubilee celebrations of Indian Pharmacological Society in February 2018. Professionally, sir is a part of many memberships, like he is a lifetime member of Indian Pharmaceutical Association, Indian Pharmacological Society, Association of Physiologists and Pharmacologists of India, Association of Pharmaceutical Teachers of India, Indian Hospital Pharmacist Association, etc. So a very warm welcome to you, sir. Now I welcome our today's next speaker, Dr. Ramesh Alluri, Principal, Vishnu Institute of Pharmaceutical Education and Research, Hyderabad. Dr. Ramesh Alluri Under Sir's guidance, now 8 PhD students are pursuing their research. Sir was twice the Secretary of Association of Pharmaceutical Teachers of India, AP State, and presently CEC member IPA. He is also a member of the BOS for many universities and has participated actively as a member in many national level committees framed by PCI, IPA, etc. He has 75 research publications to his credit in peer-reviewed national and international journals, and a few of them have received Best Paper awards also. He is a life member of professional bodies like IPA and APTI. Professor Ramesh Research Group has presented its research work in more than 50 international conferences, specifically in USA, Europe, Dubai, Australia, South Africa, and Malaysia. He received projects worth more than 2.15 crores from DST, Foundation of MSME, etc. He is associated as one of the author for 4 books. He has written 3 books and got 1 patent and received various awards like Best Pharma Teacher, Shiksha Gaurav Puraskar Award, and Best Principal Award. Alcorn State University, USA, recognized and gave him an Excellence Award. A very warm welcome to you, sir. Now, all the experts are invited to lead the session. Thank you.
Thank you for the wonderful introduction.
Thank you. Thank you. It's a prolonged introduction, but we felt really happy.
Yeah.
Doing.
Yeah. I think we can
Yes.
start the session, Ishwar.
Yeah. So thank you for a long, prolonged introduction about all of us. I think it took more time for introduction. Hope the slides are visible.
Yes.
Yes, visible.
Yes, sir. Yes, sir.
Okay. So now I'm going to cover the introduction about the drug repurposing and the scope for research and the job opportunities. Yeah. So coming to the definition of the drug repurposing, it's a process of finding new users outside the scope of the original medical indication for existing drugs. It is known as repurposing, also called as repositioning, rescuing, and a therapeutic switching. So other way, we can say the investigation of existing drugs for new therapeutic strategies. So this is a new division, I can say nowadays. The companies are started for repurposing of the existing drugs for other effects other than that are prescribed. So coming to the drug discovery and the development. So as we know, the drug discovery and the development. So discovery is different stages it involves. So discovery of the targets and their validation, identification of the lead molecules, and optimization of the lead molecules. Next, preclinical evaluation of the lead molecules, that is for the safety and efficacy studies. Safety studies that mainly for toxicity studies, which includes the acute toxicity, determination of LD50, and chronic toxicity studies, subacute toxicity studies. Later, the drugs are also screened in the preclinical models and animal models for their efficacy studies. Once the drugs, the lead molecules which are safe and effective, and which can be subjected for clinical development, clinical trials. So a drug, for evaluating its efficacy in human subjects, before efficacy, it has to be screened for toxicity and efficacy in animal models. Then it is subjected to clinical development. We know the clinical trials are conducted at different phases: phase 1, phase 2, phase 3, and phase 4. The phase 1 trials are conducted in healthy human volunteers. Then a limited number of centers using specific disease conditions. And in the third phase, multi-center study. And after proving it in phase 3 clinical trials, it is subjected for new drug application and FDA approval. And even after subjecting it into the marketing, so it is after marketing also, the phase 4 clinical trials are conducted to know the any side effects of those drugs. And this drug discovery and development, that is a traditional drug discovery and development, which is a very tedious, time-taking process, and it involves a lot of money. So if you see the picture, it is the investment in drug development by PHRMA member companies, and the number of approved drugs by FDA from 1995 to 2015. If you see the graph, so the investment in $1 billion, so it is rising, and the number of drugs discovered are very less as compared to the investment. So it, because the drug discovery, it involves a lot of time and also lot of money. So it takes a new drug to come into the market from 15 to 20 years. So the drug discovery of drugs is very expensive and time consuming, and it involves a lot of risks, and the success of drugs is very less, and hence the drug repurposing is opted nowadays for many diseases and also some disorders. So the drug repurposing is mainly to accelerate the drug development and to reduce the risk of failure, and also to reduce the cost. If you see the clinical effect of a drug compound, say a compound A, in case of drug development, there will be a single target and therapeutic outcome. So in case of the drug repurposing, the existing drugs can be targeted for multiple purposes, multiple targets, for many targets, and we can achieve the therapeutic outcome. So for this, the pharmacology of the existing drugs is knowledge and pharmacology of existing drugs is very essential. If you see the pharmacology, for example, some drugs, we study the pharmacological effect and also unwanted effects or adverse effects. Sometimes the adverse effect is also beneficial in some particular individuals, and such adverse effects or unwanted effects so can be targeted if we know the mechanism how they are produced. So one need to concentrate on drug repurposing and need to have a complete knowledge of the pharmacology of the drugs and the mechanism how they produce the therapeutic effect, and also the mechanism how they produce the other unwanted effects. So then only one can develop a new therapeutic targets for existing drugs. So there are approaches for repurposing. For example, thalidomide, so which was used for morning sickness, which is a common symptom of early pregnancy, and the new targets identified for thalidomide were thalidomide. As we know, many of us, thalidomide is a teratogenic drug, and use of thalidomide in pregnant women for morning sickness, it causes limb deformities in children. So because of that reason, it was banned for some time, but the same drug was targeted for leprosy successfully, and also another target was multiple myeloma. Similarly, finasteride, the known target was benign prostatic hyperplasia, and which is also again discovered for its effect against male pattern baldness. So another interesting drug is sildenafil, which acts by inhibiting cyclic GMP mediated PDE5 inhibition, and which was found to be unsuccessful for hypertension and angina, and which is successfully developed for its effects against male impotence, pulmonary artery hypertension, and there is a recent discovery about sildenafil. It is alleviation of altitude sickness and jet lag. You see that the drugs for repositioning or repurposing, how we get the drugs for repurposing is the drugs which are in clinical development or which are failed in the efficacy during phase 1, phase 2, or phase 3 clinical trials with no major safety concerns, and the drugs which are discontinued for commercial reasons, and the drugs patents which are close to expiry, and the candidates from the drugs from academic and institutions, and also from public sector. So such drugs can be concentrated for repurposing. Coming to the target identification, the large number of drugs have off-target effects. So there is a lot of databases are available for getting the number of drugs from sites like Drug Bank, Potential Drug Target Database, Therapeutic Target Database, Super Target, like that. They provide drug targets and drug profiles, which covers many targeted drugs we can target. So there are a number of drugs that are available. If you concentrate on, if you see the classification of pharmacological drugs, if you go into our textbooks, you can see number of classes of drugs for each condition. Like for example, antihypertensive drugs. If you take antihypertensive drugs, there are a number of classes of antihypertensive drugs, but actually they are not in use. All the drugs are not in use. Many of the drugs were, once they were used and discontinued, or some of the drugs were found to be having other side effects, and such drugs can be taken into consideration for repurposing, and they can be modified or they can be targeted for other clinical conditions. So these drugs can be screened using the novel screening platforms, like screening of compounds using in vitro and in vivo systems, high throughput systems, cell-based assays, and using small organisms like nematodes, fruit fly, zebrafish. So like this, there are a number of in vitro screening models are available for a quick screening of these existing drugs for other purposes. And use of genetically engineered cell lines, and also phenotypic approach. So all these the novel screening methods can be used for quick screening of these existing drugs. So if you compare the drug discovery with the drug repurposing, drug discovery takes more time, about 15 to 20 years, and whereas drug repurposing, a drug can be repurposed from 5 to 10 years. Similarly, the cost, whatever we are spending for getting a new drug into the market, is much more compared to the drugs, means the amount which is spent for repurposing of many drugs. So since the many number of drugs which were already discovered, which were most of the drugs are proved for their efficacy and also safety, and which are not in use, can be concentrated for their screening for other purposes. For that, what we need is, we need to understand the mechanisms, how they produce their therapeutic benefit, and also the mechanisms how they produce the adverse effects or unwanted effects. So using that knowledge, one can target the existing drugs for other therapeutic benefits. So one wonder drug, what we can say is aspirin. So aspirin, which is discovered more than 100 years back, and which was used for many years as an analgesic, and later which was withdrawn for few years because of its effects on gastrointestinal system, as it causes excess secretion of acid and causes ulcers. But later, a small means it also got other effects on the hemobiology of on the blood, like it has got antiplatelet activity. The small doses of aspirin, which produces antiplatelet activity at low doses, the doses 75 mg to 150 mg, and which is the later discovery of aspirin, and which is still in use as antiplatelet agent. So there are many drugs which were repositioned or repurposed That is one example is sildenafil, and the original indication is angina and hypertension, but which was not successful. But later it is indicated for erectile dysfunction and pulmonary hypertension. Thalidomide for morning sickness, but later it is developed for leprosy and multiple myeloma. Raloxifene hydrochloride, which was indicated for osteoporosis in post-menstrual menopausal women. And the new indication is for breast cancer in post-menopausal women. Similarly, amphotericin B, which is antifungal agent for fungal infections, which is also now targeted for leishmaniasis. Then, as I told you, aspirin for inflammation and pain. Then now it is used as antiplatelet agent. Amantadine, which was used for influenza, now which is being used for Parkinson's disease. So like that, there are many drugs which were repurposed already for many other new indications. So like this, many drugs are repurposed. I have given the list. It is available in the internet. I got it from the net only. You can search. And there are many other drugs which are available, still available, and which can be targeted for different other pharmacological activities at a different doses. Since their safety and therapeutic efficacy is already established, and their development is into for new purpose is easy, much easy compared to discovering new drugs. So the drug repurposing in India, so for tuberculosis, HIV infections, malaria, and neglected tropical diseases like leprosy, lymphatic filariasis, leishmaniasis, that is called as Kala-Azar, and also for lifestyle diseases like diabetes, hypertension, cancers. So there is even after developing repurposing of any drug, and which need to be patented, but there is a law like under the Patent Act of India, use of patent for a new indication is not permissible for any for an already patented drug, which need to be known before going for developing, means repurposing any drug. And we need to understand the laws behind the patenting of drugs. The companies which are dedicated for repositioning in India, like Conaxius in Bangalore, Jubilant Biosys in Bangalore, GVK Bio in Hyderabad, and many other companies. Nowadays, many companies, they are starting a separate division for drug repurposing. So there is a lot of scope for research in this area. So for that, one need to understand the pharmacology of each and every class of drug, and about the drug adverse effects majorly, and the mechanism how they are producing the adverse effects. So there is a lot of scope for the students in this area, because the knowledge, the young knowledge is very essential for repurposing of the existing drugs. So there is a lot of job opportunities in the industry in this area and which is going to be further developed, in industries. So this is some basics, some introduction about the drug repurposing. So thank you. So I'd like to conclude. Thank you, Ananda.
Wonderful, Ishwar. Thank you for sharing a glimpse of the idea about repurposing. And I think I wish Shushru can proceed further before I take over. Thank you.
Thank you. Thank you. Thank you.
So, yeah, thank you for giving me this opportunity. And in between, Dr. Bhavani Garu, you would like to say something, or I will just continue?
You can continue, Shushru.
You can continue, sir.
Okay. So, first of all, I should appreciate the team. The name Arogya Raksha is very apt for all these sessions we are seeing from last 2 days. So, everything is based upon benefits for human comfortable living. So, just before starting this my talk, I would like to tell that although they named expert session, but I think we are still learning in a learning stage, and expert is not the right term. What do you say, Ramesh and Dr. Ishwar?
Yeah.
So we are.
Yeah, you're right.
The next one is whatever I'm going to talk now is like almost like repurposing issues, what Dr. Ishwar has been introduced. And I think the repurposing my talk is also a recession talk, because part of the slides may have the same information, but in a different perspective. But I will try to express whatever I learned through this drug repurposing. And I hope the inputs will benefit for the students and other faculty members. So here I'm going to share my file, and please let me know if my screen share is properly visible. So somebody can tell me whether my screen sharing is apt and it is visible.
Sir, it is visible.
Yeah.
And what
Yeah.
about my voice? What about my voice and video? I hope you can listen to my voice and video as well.
Yeah.
Yes, sir, everything fine.
Yeah, it's
Okay.
good, sir.
Thank you. So just for an extension and based upon my research of interest, I'm going to have this session in my talk in two chapters, like very small one. So number one is what Dr. Ishwar has been already told about this drug repurposing and introduction aspects. Anyhow, because I made a few of the slides to show, so I think it's a repurposing and resessioning. And the next chapter, I'm going to talk about the repurposing opportunities and future for the neurodegenerative diseases or disorders, because that is the area of my interest. And we are always looking forward for repurposing for which can be helpful for neurodegenerative disorders. So basically, we can say that all living species or all living organisms, we are just like machines, and we also have subject to some dysfunction. And sometimes the dysfunction can be internal, that is physiological, and sometimes the dysfunctions can be from external source, that is from environmental source, for example, bacteria, virus, or whatever COVID-19 we are experiencing. So these are pathological disorders or dysfunctions. So the idea of the dysfunctions, and if we cannot control or if we cannot fix these dysfunctions, ultimately they may have a malfunction through entire body systems, and they may completely seize the body functions and ultimately lead to death. So since prehistoric times, most of the professional or most of the practitioners, they're having a challenge in understanding these dysfunctions or diseases or malfunctions. And that study which evolved understanding these things is the medicine, and nothing but trying to diagnose and prevent and treat various diseases. So, another way is to stop this or to alleviate these impairments. It is really a daunting task. It's a very hectic task for both biological perspective and also the legal perspective. So in this regard, the doctors and healthcare professionals, they play a major role, and they try to adapt a number of tools engineered throughout the years, and they're trying to establish some well-known and perfect drugs. So the most common used ones are the medical devices or some small molecules, which we which we name as drugs. And these drugs, however, if properly used or if not properly used, they have both the benefits. So here, what I would like to say is, discovery or getting a new drug, it is quite time consuming, it is expensive, it involves billions and billions of dollars. So it's a great challenge for the drug discovery or drug discovery team. So for a simple glimpse about drug discovery, which Dr. Ishwar already mentioned, like traditional workflow, how it happens is always like a trial and error process. So the term discovery came into existence because we don't know until we get a result. So the operation, the process starts by picking up a disease of your interest, selected in terms of market size in the sense, like you take a disease which is very well spread throughout the world or a pandemic. And if you try to make a drug to cure that disease, definitely you're going to make some money. And also clinical needs. So how devastating the disease is. So all these things are the starting points for a drug discovery. And what we do the next is, we will take a large collection of chemicals, like Dr. Ishwar told, from drug banking and some from several academic and public sector labs and all those things. And then we keep on experimenting and try to see if any relevant effect in regards to the chosen condition or chosen indication can be produced. So how can we do this? Basically, we use the drug discovery projects usually use two techniques. One is the target-based, wherein we choose a molecule where it can specifically bind to the protein and to the receptor site and exhibit and response, which might be inhibition or which might be activation, whatever is necessary. So basically, we try to take we take some molecules which are very specific and targeting particular protein or receptor and then exhibiting the response. The other type is phenotypic. In phenotypic experiments, what we do is we take some cell lines which are related to particular disease. For example, if somebody is studying about liver disorders, they use hepatocytes. Somebody is studying neurodegenerative disorders, we use neuronal cell lines or microglial cell lines. And then we try to treat our novel molecule or drug and see whether there is any positive effect or some promising results. Or simply we try to make an animal model. And for example, we make diabetic models and we make Alzheimer's models or Parkinson's models. And we try to develop these more diseased models. And then we try to treat with the new drug for any expected results or any promising results. So while doing this, we are actually missing several things. Now, what is that missing point is the need of the hour. So here, one big problem is drug development can be time consuming and very expensive. It takes more than 10 years and it costs about billions of dollars. And also recently for drug discovery, the investments are very high. So industries are not ready to spend this much of money for an unknown drug, which they don't know whether it can be really useful, benefited, or it is simply abandoned in the process. So these things are very important for the drug discovery programs or drug discovery projects. So what is the main point about this is, here, when the drug discovery programs or drug discovery projects are undertaking some research proposals or research data, so you can see on the right side of my slide, the figure which is showing, here you can see there is a straight approach. So just you focus on the central part of this schematic diagram. So here we use some particular disease or a main indication, and then at the bottom we start with a small molecule and then try to bind it to the specific protein molecule, and then whether it is involving in the mechanism process of what we are thinking, and finally it is curing or having any effect on the main indication of the disease. This is the only step what drug discovery programs or drug discovery projects will focus. The missing lines are those which are given on the right and left with the dotted arrows. So sometimes the small molecule may bind to a separate protein or a receptor, which is called as an off target. And then it may be involved in some other process and also help in curing other disease. So this line is completely ignored. And also when you look at the left side, that is the same protein or the same target molecule can show an effect in a different molecular mechanisms and also exhibit relevant to the particular disease of that particular mechanism. So these left side and the right side views are completely missing, and normally the drug companies or the research and drug discovery companies usually go through a straight line. So they have a reason for it. So here comes the chance of repurposing. So the term repurposing, discovery of new indications for approved or failed drugs. So this is, I thought, in my view, this is a classical example. So everybody know about Legos. So using the Legos, which we purchase for a huge price, box of Legos may be about $100 or $200. So these Legos can be made using these Legos. You can make several, right side, you can see several objects. You can make dinosaurs, you can make some camels or dogs, whatever. Again, you can completely re-scramble, completely remove all these Legos, and you can try to make some other toys. So this is nothing but the idea of repurposing. So what we are doing is the Legos can exactly fix to another Lego block, or it can also fix to some other shape of Lego block just by matching the dots and the grooves. So this kind of repurposing, I think everybody from their childhood who played this kind of Lego games, they are already into repurposing. And recently, several authors and several researchers, they started using different terms. We can call them as synonyms. So somebody asked about drug repositioning. Repositioning means keeping the molecule from one to for the use for the another disease, or reprofiling, or retasking, or repackaging, or recycling, and or therapeutic switching. So all these are almost similar, maybe a slight difference, because repurpose is we are using for a different purpose than the original claimed purpose. And reposition is we are moving the molecules used from one drug from one disease indication to another disease indication. In any case, most of these words are being used regularly for as a synonyms for repurposing. And here also we can use the repackaging. So keeping all the old ideas and practices and then putting into modern innovations and keeping them alive. This is the major point. The idea of repurposing is keeping the drug molecule alive and attractive. So Dr. Ishwar already explained some of the drugs which are completely blocked or abandoned, and how they are again brought into life and living throughout the use for other diseases. So here, now, where to find these molecules, or where to find these drugs for repurposing, and what is the motivation behind? So in this case, identification, mainly you can get the repurposed drugs from approved marketed compounds used daily in clinical settings. So already used drugs in clinical settings. So you can use this for repurposing. And also you can use drugs that are shelved. Shelved means drugs which are completely kept aside without any use, and then namely molecules that did not succeed in clinical trials. So molecules which did not succeed in clinical trials can also be used for repurposing the existing drugs. And the third category is repurpose from drug discovery projects. So many a times when the drug discovery projects are undergoing, there is a chance of several disadvantages, like, suddenly there may be some financial problems, suddenly there may be some other technical issues or other resources, and these may completely block the idea of using the drugs. So now here we can simply use these discontinued, for some reason, the drugs which are discontinued, you can use these things for the repurposed drugs. So, and then from the motivation behind it. So why we have to do this and what is motivating? Possibly the further market. So you have to extend the market, and also you have to extend the application line. So just by repurposing the drug, you can keep the drug in the market for another purpose, and you can completely extend the application. The second one is patent life. So you can also extend the patent life of a drug, thereby increasing the revenue, because as we discussed, there is a lot and lots of billions of dollars involved in drug discovery. And when you have to use the same existing knowledge drug for repurposing, you can simply get some revenue from this repurposed drug. Finally, the most important one is the use of treatment of rare, neglected, or degenerative diseases and disorders. So this is the motivation or motive for the drug repurposing. And there are some issues where we have to understand for this. So here one should understand, how is it possible for a drug to play multiple roles? So normally drug discovery teams, they never bother about this when they are doing in a streamline, which is shown earlier in the schematic diagram. And what is the molecular rationale? And why does the drug discovery process not automatically identify? So drug discovery teams will not identify the other indications, the other uses of the drug when they're actually performing a drug discovery. So the first thing is how it is possible for a drug to play multiple roles. So in many cases, the drugs are almost like a lock and key model, or like we call it as a magic bullet concept. You take a molecule, specifically bind to some target, and during its course, it shows some benefit to particular disease. This will not happen. Drugs definitely will bind not only to the specific target, also bind to some additional targets, and they may show some side effects. So there is a limitation. Next one is the molecular targets involved in multiple biological process. So here, the left side, the same thing where the drug binds to one protein target, it has a multiple biological process. This term, we call it as polypharmacology. Polypharmacology means one drug molecule having benefits for different disease indications. So completely this step and this step is completely missed. And we have to understand that these are the possibilities where a drug repurposing can be done. And then strategy for drug discovery programs. Strategy is nothing but cost and time. So if you try to unnecessarily keep one molecule and try to establish a big profile, trying to find activities for various diseases and various targets and various receptors, so this will not work out for an industry. Generally, they will only focus for one target with one molecule. So if they go on a side track, definitely they'll be ending in a no man's land, and definitely it is a big loss of money and time. So here, what we can understand is the purpose of the drug repurposing is a very interesting and very advantageous topic for the coming and the near future studies. So okay, I'm going to keep the next slide. So where is this next slide? So, okay. So here I would like to tell you some very interesting story, which I think Dr. Ishwar already explained, but somewhat catchy. So what happened here is when sildenafil was first discovered as a drug for, especially for angina, you know that angina is like a chest pain, and this drug used to supply the blood and increase the blood circulation for the coronary arteries. So what happened during this course is, in clinical trials, it did not show the efficacy, and thereby the drug industries or drug discovery programs have to stop this process. But during this course, there are several patients who took this drug. They came to these doctors telling shyly, they felt very shy and telling shyly that they have a side effect. And the doctors asked, what is the side effect? They told that it is this drug is giving a prolonged erection. So this is a big problem. Suddenly, this idea got into a boon for making this wonderful blockbuster drug called Viagra for erectile dysfunction patients. So thereby, it really helped for the millions and millions of people for enjoying their social life and also enjoying their family life. And almost $1.5 billion business is being happening for this simple repurposed drug, sildenafil. And not only that, this drug also is repurposed for treating pulmonary arterial hypertension, wherein maybe there is a thrombus in the lung circulation and there may be some pulmonary disorders. So this drug can also be used for this particular type of disease. So here, the main role is repurposing from the clinical side effects, repurposing from clinical side effects. The drug which showed clinical side effects can be used for other purposes. The side effects have become a very good choice of drug for another indication, that is erectile indication. The next one, the next slide which I would like to tell is about the second drug, that is, so I think every time I use this annotations, it is actually stopping my work. Okay. So the next one is the thalidomide. So these are successful stories. So again, Dr. Ishwar told about this. So this drug, when it is actually used as a treatment for sleeping inducing or morning sickness in pregnant women, they found tragic and very severe skeletal birth defects. Like you can see on this image, a small boy with having like a seal limbs, and it's also called as a seal limb disease. So it caused some teratogenicity. So this drug is completely banned and out of the market, and the drug companies or patented companies, they completely lost huge amount of money. Now, from this hazardous drug, the repurposed drug is being used for the erythema nodosum leprosum, also called as leprosy. So you can see some patients came with these red spots with high pain, and the doctors also thought, okay, let us try this drug. And within no time, just in 2 or 3 days, the patients came back with a smiling face, telling that their pain is completely reduced, and also the red dots or red sores have completely been eliminated. And during this course, there is also an off-label use of this drug for multiple myeloma. So here, multiple myeloma usually occurs in the bone marrow, and normal plasma cells will become abnormal, and it may lead to some cancers. So it is also being used for this. So what is the story we can learn from this is, the story teaches that the drug which is harmful in one patient population, that is pregnant woman, and can be highly beneficial for another. So this is the second successful story. The third successful story is raloxifene. Now this story, this drug actually helped for expanding the application, So what is this expanding the application? Initially, the drug was marketed by in the name of Evista by Eli Lilly for selective estrogen receptor modulator. And then it is repurposed once the patent issues and all the expiries have been done. The same drug have been repurposed for being used in osteoporosis. And once this drug indication has been completed, then it is being used for postmenopausal breast cancers. So for breast cancer. So in this way, this molecule explains, and it's a very good example that one drug, if it is really active for multiple indications or for various diseases, this single molecule can be in the market for a long period of time just by changing the patent rights or just by changing the drug indication or disease indication, and then it can be continued. Now, this is like helping to get a lot of revenue and also keeping a good molecule in the market. So these are the three classical examples for the understanding or the need and necessary for the drug repurposing. Now, once we know about this repurposing and the advantages of repurposing, so here we should also understand about the intellectual property rights and other legal aspects for drug repurposing. So you all know that not only the drugs, any product which has to be marketed needs some patents or intellectual property rights. Same goes the story with the drug. But drug has more values or more rules because ultimately it is for the life-threatening or diseases for humans or living subjects. So this has more importance. So drug repurposing, when you're trying to bring it to the market, it has to address many issues like technical issues, like medical issues and regulatory issues. Also, we have to understand about the marketing hurdles and while developing the drug and also while commercializing the drug. So we need to understand about this, the intellectual IP rights and legal matters. So this proper strategies that include the IP and legal inputs can transform a drug into a very successful one. So if you properly apply and properly file the patents and take the intellectual property guidelines properly, this is a really successful story. But sometimes due to the liabilities or lack of knowledge of application for getting these patents or intellectual property rights, several drugs can be simply of low significant value or they miss their significance. So these issues can be addressed. So whenever you have an idea of producing a molecule which has some indication or repurposing a molecule which has indication, the best idea is to consult a legal counsel and then you discuss the issues of how you can bring this repurposed drug into the market without any hassles. So the main issues you can see for intellectual property rights is the loss of exclusivity. This is a very good term. What is loss of exclusivity? For example, in a very common terms, I am trying to make a drug, repurposed drug for which can cure some symptoms of Parkinson's disease. So I made a patent and I made some applications and I made all the necessary things. Parallelly, somebody or somebody else is also trying for a different drug for the same disease indication. If, for example, this product which I am trying to bring is a little bit delayed and the product parallelly which they are trying to do it has been first announced into the market, there is no fun for me to release the drug again into the market because there is nobody to buy because already there is a drug which is acting in the market and it is already proving. So there is no way that I have to prove again and I will generally definitely waste lots of money in doing so. So that is exclusivity. So you have to be very exclusive and you have to be the first whenever you want to do this. And then the patent term extension is also very important. So whenever you have a chance, when you apply for a patent, initially with small in vitro or in vivo data in cell lines or animal models, you just apply for a patent and keep the patent for your clinical studies. So you don't know how long it takes. So you have to produce the results and keep this extension of your patent, at least for the term what the FDA or Indian patent rights will issue for at least 5 years, other than the 20 years what they give. So this way, again, you can keep this repurposing drug into life and try to generate some revenue out of it and for also benefit of the humans. Next is skinny labeling. Now, this is a very interesting word. What is this skinny labeling? Skinny labeling is, for example, if a drug has several drug indications, so it has several drug indications, and then when you patent, we should not try to give all the indications in one patent. So you try to give only one drug indication for at a time. And then once you finish this term, and then you give the drug indication, another drug indication for the same drug. So this kind of labeling should be given so that you will not keep all the drug indications set in one label, and thereby you lose most of the information. And the third one is continuation of the product. So we call it as the product hopping. So one drug used for one disease, for example, we have seen here, can be hopped for another disease like osteoporosis, and later it can be hopped for another disease. So this is what we call it as expanding the application line. like hopping the drug indications from one disease to another disease. Is it illegal? So several times it is not, it is illegal. But if you properly take the advice, the legal advice for these intellectual property rights professionals, so you can get a very good chance for keeping this continuation of the product, or we call it as product hopping. Now, this is what I would like to discuss about the drug repurposing and what is the use of this drug repurposing, and 3 classical examples, and some knowledge about the importance of intellectual property rights necessary for repurposing. Now, I'm going to switch to my second talk, or second agenda, or second chapter, that is about the repurposing of the molecules, existed molecules in neurodegenerative diseases. So before starting this talk, I would like to tell you some interesting story. So you might be knowing about the great Egyptians. So in ancient Egyptians, they used to believe the heart is the most important organ than the brain. Egyptians, when the king died, usually they do the mummification. They used to remove all the necessary, or all the internal organs, including the brain and liver and whatnot. Just keep the heart, because the Egyptians believe that heart is the main source, and heart is the source for human wisdom, and also the center for emotions and memory. So whenever a king died, for example, King Tutankhamun, when he is dead in a very early age, I don't know the particular reason. Somebody says about some bone disease, or somebody said it's about some malaria. We don't know. But when King Tutankhamun died, his mummy was kept intact, mummified, and there is also a golden mask kept over him. And they removed all his organs, and they kept the heart intact near the same position. So even they believe that there is an afterlife. Once the important people are dead, there is an afterlife, and they used to come back. So when they have this afterlife, somebody has to tell that you are the king. So they believe that heart is the correct wisdom and truth. So heart will explain the king that you are the king of Egypt, you are the king Tutankhamun. And also, while keeping the heart at this position, they used to make a judgment by using this balance, keeping the heart on one side and keeping the feather of truth, we call as mat. Ancient Egyptians believe that this leaf, this feather is one of the important part for the truth, a true character of the king who died. So it has to be always, the heart has to be very lighter than the feather. So which is not possible. But sometimes due to keeping the very large feather, might be from ostrich feathers, they used to always see that the heart is very light than the feather. So when the heart is very light, they believe that he's having a true character. And once he's alive, rebirth, and then this heart can explain him about his kingdom and about his royalty. So my question is, if really Tutankhamun, really, if he's having an afterlife and he comes into rebirth, can he really remember? Can the heart explain that you are the king and you are the main person for this kingdom? Can a heart explain? I don't think so. Heart cannot explain. Now, the next one is also the, what do you call, the, okay, let me again, I don't know how to do this, but okay, let me stop. So the next one, even the Aristotle in the 4th century BC, he used to have this idea of cardiocentric hypothesis. So cardiocentric hypothesis is something like believing the heart is the most important organ of the body. And he also observed in some chicks that he observed the heart first. So he thought the heart is the most important organ, and it is a seat for intelligence and emotions and sensation and whatnot, everything. But however, Hippocrates later, he is the first person to suggest that brain was the seat of the soul and intelligence, and it is not heart. So you can see many times, you can see cinemas, you can see girlfriends and boyfriends talking about heart. I really love you from my heart. My heart says I love you. My heart is really paining. I love you from bottom of my heart. So if anybody talks about heart and emotions and memory, it's a trash according to science. So please don't believe if somebody says, I love you from my heart is paining for you, my heart is crying for you. Never try to believe that guy or that girl, because heart never has any emotions. Heart cannot keep feelings. Then what is the organ which keeps all the feelings? So we don't want heart, and it is the brain. So brain has all these things. So brain can have memories, brain can have motion, sensations, love, greed, or weeping, whatever. So from next time, you have to use this symbol instead of using a heart and an arrow. So this is also called Cupid arrow of love, but we slightly changed as keeping the heart away and keeping the brain inside. So next time, whenever you want to propose a girl or a boy, or girlfriend or boyfriend, you can just tell, I love you from my brain. My brain says I love you. My brain is weeping for you. So this is the right word. So I think this makes sense. So here, even though our heart is not the major organ, but when brain remains the major organ for your memories and emotions and all those things, due to its very complex nature, due to its high complexity, it is the most vulnerable organ, and it is the most easiest organ for getting a very strong degenerative diseases. Degenerative diseases are not like just fever. So they are progressive. So we don't know when they start, but they keep on continuing inside your body without showing any effects until they reach in stage 2 or stage 3. So this is what we are trying to focus on. Now, brain is the control center for the body. It has controlling on thoughts, memories, and speech, and movement, regulates the functioning of other organs. So it is also called as a big boss. However, when problems occur, the results are very devastating, and it can be due to our lifestyles. So generally, we have a habit of having franken foods or junk foods, and have some unwanted habits like smoking, drinking, and whatnot, drugging, and all those things. So lifestyle related causes may have a damage to your brain. Infections, in fact, and some part of genetics, and nutrition related causes, and environmental influences. So outside pollutions and many other things, and physical injuries. So if there is a trauma or an accident of the brain, so you may have this progressive neurodegenerative disorders. So out of several disorders, we are mainly focusing on these things, but some of these disorders for brain, number 1 is Alzheimer's disease. Everybody know that. And number 2 is Parkinson's disease, and amyotrophic lateral sclerosis, and Huntington's disease. So I'm going to focus on these 4 neurological or neurodegenerative disorders, and try to give inputs about the number of repurposed drugs which are currently being used. So here, neurodegenerative disorders, they are age dependent, and as you grow old, slowly your neurons will die because there is no regeneration as so far. And it may be fatal degenerative diseases. So as of 2050, maybe more than 150 millions will be having this neurodegenerative diseases. And even the World Health Organization predicts in the next 20 years, it will become the most important problem, more than the cardiovascular diseases. So normally cardiovascular diseases are number 1, then slowly diabetes related issues are reaching, and then the neurological diseases. But I think next 20 years, the neurodegenerative diseases will come into the first position. So several academic labs and biotechnology companies, pharmacy companies, they're trying to find some targets and identify some optimizing compounds, and conducting clinical trials for attempting and to prolong or to reduce these neurodegenerative diseases. So the difficulty is having a proper treatment agenda, and also it has to be approved from many other legal issues. And the most disgusting part is from 2005, there is no proper drug which actually entered into a market for neurodegenerative disorders. So always we are using the same old existing one, and the four major important diseases which I'm going to talk about now is the first one is Alzheimer's. So slowly destroys the memory and the thinking skills. So you can see the image, like completely the midbrain is completely degenerated. So Parkinson's disease also similar. It affects cognitive functions, but motor skills are also affected, and mainly due to the area called substantia nigra, where the dopaminergic neurons are highly situated. And the third one is the ALS, amyotrophic lateral sclerosis. So this is about the involuntary muscle movement effect, and also the spinal cord. So you can see normal is a very thin and perfect, but the ALS patient has an enlarged and rigid the spinal cord. And the fourth one is something genetic disorder, and also it affects the muscle coordination. And you can have many famous people, I don't know how many of you can recognize here, but I think definitely Ronald Reagan, and this guy on the right, extreme right top, he is the Star Trek actor, James Doohan, and the guy with the gun, so he's also an American actor, the Charles Bronson. And the last one is Etta James, a very popular American singer. So neurological diseases, disorders, they did not leave anyone. So for example, Parkinson's, we know Adolf Hitler, Chinese King Mao Zedong, and Pope John Paul II, Muhammad Ali, boxer, S.R. Arafat, the Michael J. Fox, the actor, Hollywood actor, and Francis Franco is a dictator, Spanish dictator, and Salvador Ali also is an artist. And Robin Williams, we saw many movies of him, and he's also, so you can see several people with Parkinson's. And for example, Huntington's, you can see towards this guitar guy, that is Woody Guthrie and Trey Gray. So all are great personalities. We really don't know them because we are not interested. We are only interested in Hollywood movies and maximum Hollywood movies. But I don't know anybody's suffered with Alzheimer's and Parkinson's or HD. So I could not keep the images. I tried in the net, but I could not find. And especially the amyotrophic lateral sclerosis, you can see Stephen Hawking, one of the great person who know that he's going to die, and he made several discoveries and he used to speak with a very specialized device. So these are what we can see or what we can identify from these pictures is it did not leave a dictator, it did not leave a leader. These diseases did not leave the musician or a boxer or a religious person like Pope John Paul II, or actors and girls or boys. They did not care. So there is no caste, creed, religion, anything for these neurodegenerative disorders to occur. So here we have a very huge target or very huge drug therapies, especially for repurposing. So what we are doing, there are three chances. One is synthesizing new compounds. One is natural products. The other one is existing drugs. Existing drugs are what we call it as repurposing or drug repurposing. So at this point of time, finding a new molecule and spending 20 years, spending billions of dollars, the drug discovery companies don't really believe in it. They want to use a repurposing purpose, repurposing these drugs. So if you see on the right side, especially for particular these four important disorders, you can see there are several classifications of pharmacological drugs like antimicrobial, anti-asthma, anti-cancer, antipsychotic, anti-cancer. So CNS stimulants. So majority of these drug indications or the class of compounds, class of drugs which are used for other diseases are being tried for neurodegenerative diseases. So first one is the Alzheimer's. And as I discussed about Alzheimer's, so I don't want to go in depth. So you can see on the right side of this brain slice, so there is an extreme shrinkage of the cortical, the cerebral cortex, and also there is an elapsed ventricles, and also the hippocampus area is being degenerated. So currently there is no drug. At least 1 in 9 people aged about 65, they are facing this problem. So they have several associated problems. So far the main mechanisms, what they have studied is amyloid precursor protein area, or the NMDA area, or amyloid beta aggregation, or tau phosphorylation, or hyperphosphorylation, formation of amyloid plaques, which you can see on the left side figure, and then neurofibrillary tangles. So these are actually experimentally proved that the amyloid plaques and NFTs are major role. But nowadays, it's been advancing and new mechanisms have been started. So we are using several drugs. So we use cholinesterase inhibitors, we use NMDA blockers, we use beta secretase inhibitors. Like this, we also have drugs in the market. But all these drugs cannot cure or cannot treat completely, but they are only used for symptomatic relief or curing the associated diseases. Now, I don't say that once you repurpose a drug, definitely it is going to be a miracle and it will completely treat the neurodegenerative disease or Alzheimer's disease. No. Sometimes due to trial and error methods, we may have a very classical drug which can help for treating. So here on the right side, you can see several structures like placlitaxel and thalidomide, or you can see erythromycin, rifampicin, doxycycline. So several groups, antimicrobials, the myopathies or anti-cancer drugs. You can see some antiviral drugs. So these are the repurposed drugs which are under trials for Alzheimer's disease. So antifungal, antimalarials, and anti-asthma, antioxidants, anti-ischemic drugs, hypertension and angina drugs. So several drugs which are now used for repurposed. And the second most important disease is what we call Parkinson's disease. So in Parkinson's disease, it is also called as an SA shaking palsy, named by James Parkinson's. It is the second most deleterious neurodegenerative disease. So it has an indication called TRAP, like tremor and rigidity and echinacea and postural instability. I'm not going to discuss more about this disease, but let us see what will be the problem. Like in the substantia nigra area, deep inside the brain, there is a rich area called dopaminergic neurons. And due to the degeneration of dopaminergic neurons, this particular condition may arise so far. So again, it has memory problems, it has motor problems. So far the drugs being used are dopamine mimics like levodopa and carbidopa, and dopamine related agonists or catechol methyltransferase enzyme inhibitors, or monoamine oxidase B inhibitors, or dopa carboxylase inhibitors. So these are some of the drugs which are being used at the current situation. But again, it cannot be cured, and no proper drug has been discovered so far. So you can see the repurposed drugs here, like terazosin, which is used for prostate enlargement. Now it is being in phase 2 clinical trials for neuroprotection in PD. And ambroxol, which is used for mucus clearance in respiratory disorders. Now it is also in phase 2. And exenatide or liraglutide, these are diabetic related drugs, also in phase 2. And buspirone, which is used for anti-anxiety, also in phase 3. And nilotinib in phase 2, and amantadine, which is used for influenza. It is now being used for, in one area it is used in phase 2, and in another drug indication it is being used in phase 4. So these are some of the repurposed drugs for Parkinson's disease. So you can have the structures here, but I think I'm not a chemical guy to explain more about the chemical moieties, but I can say that some CNS stimulants, some antioxidants, some anti-epileptic drugs, influenza or anti-asthma and diabetic drugs have been repurposed for usage in Parkinson's disease. So on the right side, you can see positron emission tomography or PET scan. The top one is the normal brain, and the bottom one is the diseased brain. You can see no activity. Normally, whenever there is a scan, it should be very thick red or orange color. Then it shows there is an activity of neurons. But if there is no red orange images and it is a blue image, that means there is no electrical stimulus or electrical impulse happening, and there is no utilization of this dye, and only blue color can be seen. So in this way, many repurposed drugs are being used for the Huntington's disease also. So again, here also it is like degeneration of frontal horns, and again it is a genetic disorder. So especially Huntington gene is responsible. It shows some choreatic movements, involuntary choreatic movements, and most of the drugs are used for stopping this chorea symptoms. Again, here you have so many type of drugs like monoamine transport 2 inhibitors, or prevent HD choreas and decrease Huntington protein. So you have tetrabenazine, and also it's in clinical phase 4. So this is one of the most best example of drug. So here some chemical structures, and you can see antipsychotic drugs, You can see schizophrenic drugs and antipsychotic and NMDA inhibitors. Because most of the drugs, at least they will try to improve your cognitive function, they will try to improve your behavioral problems or sometimes physical impairments. So till now, still there is no full detailed drug which can completely cure or treat Huntington's disease, and repurposed drugs are in gaining their existence. So the last one, the last major disease, which is the amyotrophic lateral sclerosis, you all might be heard about this ice bucket challenge. So this is the challenge which was created for the awareness in ALS. And you can see the left side image, the famous Stephen Hawking. So here again, nerve cells actually give stimulation to the muscle. And because of this Huntington gene or some other related genes, this response is been destroyed, and the muscle content or muscle rigidity and elasticity is being lost. So people cannot move. So here again, some anti-cancer drugs like Mastanib, some anti-HIV drugs and anti-retroviral drugs and anti-estrogen drugs, epileptic drugs and anti-HIV drugs are being used for as repurposed drugs for the ALS. Again, trying to give some symptomatic relief like respiratory distress or muscle atrophy or muscle rigidity and muscle weakness. So these things can be controlled and prolong the progress of neurodegeneration in Huntington's, in ALS can be done. So now I would like to tell about our story, which we have done from our lab. So you can see on the right side, this is my university, Konkuk University. It's almost having 80 years of history. And this is the main building. The right side building is the office where we work. And this is the whole map. So we did some repurposing experiments on cordycepin, which actually it is used for chronic myelogenous leukemia in the original indication. Now we are trying to use it for testicular dysfunction. And melatonin, you know it, it is a hormone which is helping for improving sleep. Now we are trying to have an effect on anti-inflammatory, especially in gouty arthritis. And the third one is the methylparaben, for which I came to Korea for working as a postdoctoral fellow, and I have a patent for these molecules. So it is actually used as a preservative, simple preservative, an antifungal agent, but seem to be very good for neuroprotection, especially in PD conditions. And the fourth one is imodin. Originally, it is an antiviral drug and also used for some polycystic kidney disease. Now we are repurposing this for allergic reactions. So I really would like to discuss more about this because this is my area and this is what I did. But because this is a panel session, I really want to put it short. And these are some of the papers, related papers we published in Toxicology and Applied Pharmacology, which is a high impact journal, and Neurotoxicology and European Journal of Pharmacology and Nutrients. So like, it's not just simply saying, but we also experienced the repurposing, and we had some promising results. So I request all of the persons who are aspirants to keep this into mind. And like Dr. Ishwar said, there is a very good chances for job opportunities in this area, and they may start a new division, especially division of repurposing for particular indications. So finally, I would like to conclude by the summary and future perspectives. So for neurodegenerative diseases, we know that till now there is no cure, and the quality of life is really going down. So we have to try to repurpose. Maybe in coming years, there will be a much larger research on repurposing these drugs. So failed drugs or abandoned drugs should not be completely ignored. So they have to be considered as a starting point for new molecules, or I mean to say starting point for new indication diseases. And other thing is synthesis of new compounds via molecular modification and ligand-based design should be continued. And repurposing drugs for neurodegenerations are likely to be challenging. And one thing you should remember, you should also do drug discovery. You should also do novel drug discovery, because unless you have new drug discovery or new drug molecules, from where the question comes for drug repurposing. So drug discovery should be continued. And from that, we should also try to get the drug repurposing ideas. And then I would conclude by talking about a very great person called Petsko. and he is begging in one article, like, please give me your tired, your poor, your phase 2 failures. So what if those drugs are not tried for any other disease? What if the cure for Alzheimer's disease is sitting on some drug company shelf as a potential cancer drug that failed in phase 2? People diagnosed with psoriasis, they have a testing for heart disease. And these psoriasis drugs which are failed in clinical trials should be tested for the heart diseases. So the author is trying, almost like literally begging. So he really wants the phase 2 failures. I want them for my own research and also for your research. And because they could make a difference for the host of unmet medical needs. So this really, I like this statement. And for all those who are interested in drug repurposing, you should try to follow these things for your purpose and for my purpose. And finally, this is a real old story, an old wine in new bottles, nothing but drug repositioning or repurposing or whatever you call, repackaging, recycling. So there is a story like wine used to be stored in leather bags, and after prolonged storage, the leather becomes so brittle and the wine gets leaked. So they have to take this old wine and put into a new leather bag. Directly, the wine which is moved into a new leather pouch is completely giving a new taste and new flavor and new fragrance. So in this way, the word old wine in new bottles can be accurately or aptly used for drug repurposing from existed drugs or known drugs. So with this, I really want to thank and for giving me this opportunity. And I hope that you got some insights into repurposing and some key aspects for drug discovery or repurposing in neurodegenerative diseases. So thank you so much for your patient listening. And I think I did not kill much of the time. So thank you, and over to my friend, Dr. Ramesh.
Thank you, Shushru. I think, thank you one and all. I think after a wonderful session from two experts, Dr. Ishwar and Dr. Coppola, I think already the time has passed by, and being a last batsman, I think I should ensure that I wind it up at a faster pace, because any human, right, can only concentrate for an hour max. Generally, it is only for 7 minutes, but I think, thank you once again. And I think, let me add my slides if they are visible to you.
Now you can add, Dr. Ramesh.
Yeah, thank you.
Thank you, Susru. Excellent. Well, thank you, Dr. Ishwar.
I hope you are able to see the slides.
Yes. There is an alignment problem.
Yes,
There is
sir.
an
Yes, sir. We are seeing your slide, but it is very broader. Means try to concise.
Okay.
Some more, sir.
Sir, I think you are opening.
Yeah, it's okay now,
It's
sir.
okay
You
now.
maximize.
It's fine. We can maximize it, right?
Yeah, slide share. You can keep the slide share, sir.
Okay.
No.
Yeah, 1 minute. It's fine now, right?
No.
Yeah. I hope it's fine.
Yeah. Yes, sir. Exactly.
Right. Thank you, all of you. Right. I think it's time for me to share my session. I think I'll quickly wind up in 10 to 15 minutes, I promise. But the reason why I'm still waiting for this is the real purpose of all this program is now the important one, that is regarding the outcomes of the coronavirus pandemic. And I think it's time for us, all of us, to learn something related to that, apart from the various other areas. I think, first of all, I would like to share a small picture where there are few people who doesn't want anyone in the beach, and there are people who require more crowd. And I think I just want to also share the current statistics. Just 5 minutes back, the India total people suffering from coronavirus is 2.5 lakh people. And I think particularly AP is competing with Telangana, where in Telangana, not much screening is done. This is the report as for few people, right? And I think AP has almost 4,700 participants, and Telangana has 3,650 participants, patients, sorry, who are positive. Now, coming to the other important thing is, as I told you, I'll be more focusing on the COVID and how drug repurposing can help in getting a better drug in a short span of time. As you know, the normal de novo drug discovery takes almost 15 years, 10 to 15 years, and it's quite costly. Attrition rate is very high and time consuming. And in fact, we also know that since it's a pandemic and the contaminant zone is increasing, I think we should now put our energies in the drug repurposing. And I think general statistics also indicate that we have every over 5 years, right? And I think we see only 40 new drugs are invented every year. And the success rate is hardly 6% for the new drug discovery. And this is the rationale why people are shifting their faces towards drug repurposing. And the success rate for the drug repurposing accounts for approximately 30% of the new FDA approved drugs and vaccines in the recent years. So I think this is an attraction for the income, and you can see all the shares skyrocketing. And I think that this outcome strongly suggests that new strategies and technologies need to be accelerated for drug discovery to advance the success rate of the drug. And here you can clearly see the definition of the repurposing, I think, which my already friends have shared about it, and I don't want to waste my time in it. And you know what is the use of this, and at a nutshell, the advantages are very clear, that they have to go to directly the clinical trials. They can go to the clinical trials, and the risk of failure is less compared to the normal drug discovery, and they require lesser investment, which is the most important part, where even the universities or the educational institutes also can partner now, and they can facilitate prompt clinical decisions, which are very easy now. And the most important thing, as I told you, it reduces the time frame for the development and ensures that there is a market applicability. However, there are certain patent related things which my friends have shared. And once you are successful, I think you can be a billionaire. So with these advantages, I wish to share the various examples of drugs which are quite commonly used for and which were highlighted for drug repurposing. And my earlier friends already quoted the thalidomide and sildenafil, and most importantly, the lidocaine, which is earlier famous for local anesthetic, is now used as an antiarrhythmic. So with this few examples, I just want to share this slide saying that Corona has changed the way we live and work. And I think it's hard to believe that we never expected this situation. And I think me personally was able to do all the work with a phone without even a laptop for these 2.5 months. And I think, however, now we gradually got adapted to this and we need to live with this, right? And I think there is no other go. So although we have almost over 10,000 cases triggering each day, but this is the order of life. And I believe that in future, India will be the only country which will be able to get the outcome and which can eradicate the corona, which the whole world is waiting for us and carefully watching us. Now, coming to this virus, I think I just want to add that from past 2 decades, there were these 3 viruses which were well known. That is MERS-CoV, that is Middle East Respiratory Syndrome, and SARS-CoV, which is Severe Acute Respiratory Syndrome, which I think it was in 2003, where there were around 8,000 patients which were suffering from this. Out of it, 771 patients were dead due to this SARS-CoV in 2003. And now in Wuhan, in November end, we have the last one, that is SARS-CoV-2, that is COVID-19, right? And I believe, although it was there from November end 2019, we came to know it officially from WHO only in March 25th. So this gap has made us to go a little slow. And I believe, nevertheless, we are in the progress of getting the new drug. And I think all of us know, why does the virus change? As every one of us know that there are various strains. Some of them report as 9, but majorly all the papers share that there are majorly 2 types of strains called L strain and S strain. And S strain is the original one, and later on it was converted to the L strain. And there were reports stating from CCMB a couple of days ago, an article released stated that the L strain is a little more potential and more damaging. And I think that is present in Gujarat, Maharashtra, Telangana, and Tamil Nadu, which is said to be the reason for more number of cases and the short amount of time for the death of a person. So I think you all know, when virus infects you, they attach to your cell, get inside them, and make copies of their RNA, which helps them to spread. And if there is any copying mistake, the RNA gets changed, and the scientists call them as mutations. And these changes happen rapidly by accident, and it's a normal part of what happens to virus as they multiply and spread. And you'll be not surprised to learn that only in Telangana, you may have both types of strains. And I think that is one of the reason why for some it will be active and for others it may not be much relevant. So what I want to share here is that the mutations are quite common, and we also know that the flu shot, which is very known in US, right, every year. And I think only in US, because of flu shot, around 20,000 patients die. So that is quite common there because of their lack of immunoboosters or lack of XYZ reasons. So please don't be panicked. And I think what I want to share here is we are going to see the change. Although the virus keeps on changing, it's little quite difficult for us to get the correct vaccine because of the transformations. But still, I think for every situation, there will be an cool ending, although there will be a little loss, and not only the patient loss, but more important is the economy loss. And it is said that this pandemic is going to cause losses in trillions of dollars, which never happened. Earlier, we had many, but they were only restricted to billions. So the other most important thing which I want to share is now all of us are trying for a combination therapy because not a single drug is able to cure them. And many people have registered in the clinical trials, and they told if one is not effective, the other one might be effective. And when two or more drugs are acting by different cellular signaling pathways, and that can help the therapeutic efficacy of the drugs. Because if you know some of the drugs, the best examples include antiviral drugs, right? Where some of the antiviral drugs have got a drawback of having an oral instability. And they may also have a problem with other cytochrome P450 metabolism. So when an additional drug is given, a combination is given that can improve, and the targets may be different, and that can help us in producing a synergistic effect. And the other strategy is high throughput screening methods, and that is also one of the method. However, an antiviral combination with a double hit effect may be the best choice and success, and that is going to give us the clinical related stability. Now coming to the combinations, as I told, right, many of the combinations are used, and I'll also share you the various areas which are being used. Particularly coming to the advantages of the combination therapy is improving the efficacy, reducing the dose, reducing the duration of the treatment, cost of the drug, particularly, you know, the drug discovery costs are very high. And majorly, it is the toxicity. I think we all know that majority of the deaths are partially because of drug-drug interactions or due to some other drug toxicities. And if we can reduce the toxicity, that's an boon for the patients. And above all, now the biggest worry is the antibiotic resistance, which is the one of the most important thing, and India is the global hub for antibiotic resistance because of the lack of proper usage. And if we can reduce the antibiotic resistance, or here in various antiviral combinations also, if we can reduce the doses and improve the efficacy, right, it can definitely help us in getting a better drug. Now, as already shared by my friends, I think of the existing antiviral drugs, or all these drugs which are quite known, and they are also given in combinations with chloroquine and hydroxychloroquine, anti-malarial. So a combination of anti-malarial, antibiotics, immunologicals, similarly other drugs may produce a different effects. And that's the reason you'll be surprised to know in the National Register for Clinical Trials, there were number of trials registered, and I think China is on the top of the map. More than nearly 200 clinical trials, they have officially asked the permission and they are conducting it. So what I want to share here is that antiviral and in combination with any of the other drugs also are producing wonderful results. And this is a way for the future approach. And it may be a little insight of the various drugs targeting the various areas of the COVID-19 attack. I think you can clearly see on the left, you have the endocytosis, which is inhibited by various drugs like imatinib, similarly chloroquine, and similarly we have the attachment of SARS at particular receptor targets, and we have chloroquine, which is producing an antagonistic action. Similarly, host membrane perfusion can also be prevented from remdesivir, and similarly cyclosporins. All these are some of the drugs where they are targeting at different sites. It's a glimpse of the various mechanisms which I am sharing, how a combination can help us. An antimicrobial and an anti-malarial can definitely, an antiviral and an anti-malarial can definitely have actions at various sites, at the multiple sites, where we can definitely get a wonderful drug. Similarly, we have the immunosuppressants like IFN, similarly interleukin 6R, similarly various other drugs which are definitely acting, and they are also given in combination like with certain NSAIDs. Now they are also trying in these areas so that we can get some positive advantage. And I think these are some of the things which I want to share about the official websites where you can get the current number of clinical trials which are registered. And ITCRP is the one which was the official registry, and all the others, EU, all these are pertaining to certain areas. So this is just for the information of the students. So you can log into these websites and you can get the current clinical trials, and I don't want to share all of them which I have. I think in the interest of time, I have just deleted them. So there are hundreds of clinical trials which are registered. If you also want to perform, you need to go into these trials. And I'm happy to share that Viper, our institution, is only college which has in-house institutional ethics committee, where I think probably one of it's in the south. So we do a lot of approvals. We give approvals for the clinical trials. Now, finally, coming to the treatment strategies is majorly, as you all know, antiviral drugs are the drugs which are used for the treatment. And they are also given in anti-malarial drugs combinations with the hydrochloroquine. Sorry, there's a mistake here. Similarly, they are also given in combination with immunosuppressants. Similarly, plasma-based therapy. Similarly, antimicrobials, antibacterials, like azithromycin is also given in combination, and it is producing successful results. And alternative treatment strategies, this is what I want to share. There were a number of clinical trials registered for combinations with antiviral drugs, particularly thalidomide. Similarly, they say vitamin C is the wonderful drug for the treatment of viruses, which is well known right from the traditional usage of drugs in India. So there are certain already clinical trials going on in combination with vitamin C, similarly heparin. And particularly there are studies in Italy, they are doing clinical trials sharing that aspirin also can be used. And they are all doing various clinical trials, and we don't know which will pop up. So similarly, probiotics, ozone therapy, and I think I got an idea after looking into this. I think yoga is a perfect, wonderful, energetic, what we can say, exercise, which can definitely cure the COVID. And I think I don't know, I haven't seen the yoga here, but I got an idea that definitely in combination with certain drugs, it can definitely help us to get a better medicine. And these are some of the glimpses of the treatment strategies. And finally, I think there are few challenges in clinical trials, as my friends Shushru and Ishwar has already shared, that the major problems will be that they may need again a new phase 1 trials, which require a complete and a supplementation of the data for this particular drug. And the proof of concept of the studies are also need to be done. And I think the most interesting things are majorly the challenges like miltefosine, right, which is definitely an anti-cancer drug, which they have tried, and which is useful at the doses of 100 mg for treatment of cancer. However, it has got its toxicity. But luckily, due to drug repositioning, and I think this has helped them to cure at the usage of 25 mg. It was useful for leishmaniasis. So I want to say that the drug repositioning can definitely help us in getting new drugs with more advantages. And lastly, I think this is a simple glimpse of the clinical trial dashboard, where you can see United States, China, right? All these are the number of clinical trials which are happening. And I think not much in India is happening. Now it has taken into account. And you can see the drug classes below, right? Vitamin C and all the various other drugs, azithromycin with hydrochloric drugs, which are done in combination. And this is the data related to the clinical trials. And I think finally, I would like to share that the teamwork is the only way to come out of it. I think the best example all of you know, right? We already are suffering from this, and it has gone beyond 200 countries. So until we partner with other, I think we cannot come with the productive rate. And I think you can also see, right, three of us has given insights on various areas. So definitely I strongly follow that teamwork is the key for success. And with this, I would like to thank my institution, where my research scholars helped me a lot for various fundings, and we have already got huge fundings, and we again applied for fundings on related to only COVID, and we are waiting for the results. And I think a new project is also given to DST for 2.5 crores for our society, where we are able to share the new things. With this, I think I thank all of you, and it's over to all of you, right? And thank you one and all.
Thank you, sir. Thank you. Yeah. Now this is the time for the questionnaire.
Okay, ma'am. We
Okay.
have a few questions in the
Yeah,
chat
yeah.
box.
Let's us be come onto the screen. Let them be.
Okay, ma'am.
Sir, stop the screen share.
Sorry, 1 minute. Yeah.
Sir, stop this. Yeah.
Yeah.
Yeah. Yeah, it's okay, sir.
Yeah.
Yeah. Okay. Now this is the time for the questionnaire, sir. Yeah. Ramya, you can proceed.
Okay, ma'am. So we have this first question, sir. Is the same drug which is being used for different diseases can be used without causing any toxicity?
I think I want to share that you all know, we always say that all the drugs which are effective for any therapeutic purpose has got built-in effects of toxicity. So maybe a combination of drug can definitely reduce the toxicity, but it cannot totally nullify the toxicity. It may also, but the percentage of chances is quite less. Thank you.
Okay, sir. Thank you so much. And the next question is, how can the neurons be activated even though the person is being aged?
I think Shushru can answer.
Neurons be activated, even the person is aged?
Is being aged.
See, the reason behind is, as you know, there are billions of neurons, and as you grow elder, the neurons keep on dying. Unfortunately, there is no regrowth or regeneration of neurons. So the neurons which are available at the site or available at the area of the brain, which are related to particular activities or functions like emotions or memory or whatever experiences, the neurons will be activated continuously until the death of a person. The only problem will be how much it is activated and how much he can perform the activities based upon the electrical impulses caused by the neurons. So there is no question of activation and no activation. They have to be active. There will be some electrical impulse as long as the person is alive. He cannot be brain dead.
Sir, thank you. And the next question is, what might be the exact reason for neurodegenerative diseases?
Exact reason there. See, in the slide I told you there are several reasons. Like for example, lifestyles. Although there might not be a direct attack to the brain, but there are several surrounding issues where ultimately it may lead damage to the brain. I told you the brain is a big boss. Like for example, our eminent principal, or Dr. Ramesh, is the big boss for his college, and the entire faculty, students, and non-teaching staff, everybody should be cooperating with him. Suppose some department is non-cooperative, ultimately it will affect Dr. Ramesh as a boss. So similarly with Dr. Ishwar in his department. So this is a simple logic. There's nothing in depth to understand.
Thank you, sir. And the next question is, which part of the brain is exactly affected in Huntington's disease? Is there any remedy? So you have already answered the part of the remedy in your slides that there is no exact remedy. But the question is, which part of the brain exactly degenerates?
See, maybe the midbrain related to hippocampus. And sometimes even the cerebral cortex area will be degenerated. So it is not exactly a particular point wherein you can say, like Parkinson's disease, you can say substantia nigra is important. But for Huntington's disease, it's various reasons. So there is a choreatic problem, so like movement muscle disorders also. So you cannot say exact position, but ultimately, mostly hippocampus or amygdala or cerebral cortex areas or midbrain areas should be responsible. More than the areas of the brain, as we know, it is a genetic problem. So first you should understand about the genes which are related to this Huntington's problem. And once you can repair or correct these genes, automatically I think things, it's not that easy what I'm telling sitting here, but it's not particular area.
Sir, thank you so much. And the next question is, which factor mainly dominates neurodegeneration? Is it either aging or stress?
Is there something related to the drug repurposing or
Yes, sir. Okay, sir. We will be talking about it. So,
I will tell about this. Please repeat the question.
So which factor dominates neurodegeneration? Is it either aging or stress?
It is a multifaceted disorder. So aging is also a problem, but having a good lifestyle and aging, I think there's a chance of escaping from these neurodegenerative diseases. But stress and living style and what we call unwanted habits and no thinking too much for unwanted reasons or silly reasons, not leading their life, comparing their life with others, all these things related to stress. And that is the main problem, not only for neurodegeneration. It will be a problem for diabetes, for COVID-19 also. So stress is
all stress-related disorders.
So aging is just, we say aging is a number. So I think so you have a decent lifestyle. I think you will age very nicely without any problems.
And I think the biggest factor is the highest ambition, right? Being highly ambitious is now the real cause, and virtual, more of anticipation can add more stress. And naturally, as you asked, it is the important cause for the neurogeneration. Thank you.
Thank you, sir. As you all have said, aging gracefully might not cause many of these problems. That was a well-answered question. And the next question is there a need to obtain FDA approval when the drugs are repurposed for new clinical indications?
Yes, there is a real necessary, but you can submit your preclinical data, which we have done in your initial stages for the original indication, and then provided keeping all these data plus the clinical data which you have procured during this repurposing techniques. These two can give a chance to reduce the time of acceptance, because already you have data for up to the clinical phase 1. So you don't need to show again from the beginning, because you have the toxicity profile, you have all the efficacy and affinity profiles. Only you need to focus on the new indication and what are the works you have done for the new indication and whether it is accomplishing the targets. So automatically the time will be reduced, maybe it is less expensive, and immediately it can go into the market for FDA approval. But yes, there needs an approval properly followed.
Okay, sir, thank you. So how far can we imply this pharmacokinetic profiling data of the old drug to the other targeted drugs?
I think Dr. Ishwar is the right person for pharmacokinetic profiling.
Sir?
Dr. Ishwar is here. I think Ishwar can be the right person to answer.
Yes, sir. Ishwar, sir, can you hear me? Dr. Ishwar, sir?
Okay.
Yeah, he's not there. Okay.
Okay, sir. Okay, sir. So we'll move on. So these are the few questions which are being, there are the other questions which are related. Some things like, are these neurodegenerative diseases, should the medicine be taken lifelong or they can be curable? These are some sort of questions which are being posted, sir. So do you have any views about this? Would you like to share something about this?
It is the majority of the time. So
Yes, sir. Most of the people are now posting in the questions.
symptomatic relief is a continuous process. Like if you stop some drug for a particular reason, the complications may repeat, or sometimes they may be enhanced also. So if it is some nutrient supplements or simple chemical moieties not actually working through the mechanism of Parkinson's disease or any neurodegenerative disease, you can take regularly, like you can use vitamin C supplements, you can use your tocopherols, or you can have supplements from the everyday food intake. But if it is a drug which is intended, which is having a proper mechanism of action, then you need to take care about the dosing and the dosage and also the duration and the interval. So you cannot keep on continuing the drug, because once the receptors get sensitized, or the drug may not work, and you have to increase the doses, which again will be like drug intolerance. And some time later, even if you give the highest dose of a particular drug, the patient will not respond, and that may be the end of his day. So continuous drugs, not the actual drugs for the disease, supplements can be used like every day we are using, but the drugs with proper mechanism of action should be taken care.
Okay, sir. Thank you. So there is this another question where anonymous person is asking about, when the drugs are repurposed for patients with cardiac problems, so how can they be repurposed? So are there any alternative drugs while using, or any precautions that should be taken when those drugs are being used for cardiac patients?
Repurposing for cardiac patients or cardiac problems?
Cardiac problems, sir. Cardiac problems.
The patient is getting a cardiac problem, or already he is having cardiac problems?
No, already the patient is having cardiac problems.
And what is the problem? Like, what is the problem in taking?
For suppose if the patient is being given drug, if a COVID patient is being given drug, who is already suffering from a cardiac problem, if a repurposed drug is given, so how can those be managed?
See, always there is a feedback necessary. Whenever a patient or a person is going to a doctor, the doctor clearly asks the patient what are the complications which he had previously. And he will check for any drug interactions, like whether the repurposed drug is having a direct or indirect actions over cardiovascular system or some urinary system or respiratory system. And if the patient is having similar problems where the drugs may interact and create some unwanted effects on that system. So it is not simply you, me, and like we are actually doctors by research, doctors not by practice. So the best thing is he should visit a nice doctor and take proper prescription and tell his history and get proper feedback. What do you say, Dr. Ishwar?
And I just want to add what Shushu is saying is majorly, it's a combination of two drugs as per your question. So we already know the toxicity profile of each drug. And if a next drug has got cardiac toxicity, where is the point of using it? We should never use them at all. So already we know the data of both the drugs, and when we cannot take him as a volunteer, if he has those already cardiac implications, and we should not use him as we should not enroll him for clinical trials.
Yes, sir. Thank you. And that is all for the questions.
Mr. Ramesh, you were asking about some pharmacokinetics and something. I don't know, Dr. Ishwar might be helpful.
Yes, sir.
Yeah, you can.
So the question is, how far can we imply the pharmacokinetic profiling data of an old drug for the repurposed drug? How far can the old pharmacokinetic data of the old drug can be utilized while studying about the repurposed drug?
I think 100% you can utilize the.
Yes, sir. Thank you so much.
I think
Hello.
Sure, your voice is low.
Okay, my network is not supporting.
Yes,
So-
sir. We can.
Unmute yourself, sir. It's not audible. Ishwar, sir.
Hello.
Yeah,
Sir.
it is audible.
Yeah.
Is it
I think,
audible now?
anyway, let me also add some points before Ishwar again rejoins. Is very clear that the pharmacokinetic data can be used provided if the dosage is the same. And if there is a difference in the dosage, as I told you, an anti-cancer drug at the doses of 100 mg is quite useful for cancer treatment. However, it has got its own toxicity. But in order to do the same one for at the doses of 25 mg, right? It is useful for leishmaniasis. So there needs again a clinical recollection of the data, and they may be only partially be useful for that. So pharmacokinetic wise, it is fine. But again, the doses need to be in consideration with the trial taking place.
Okay, sir. Thank you. So we have this other question. Can boosting the immunity with antioxidant foods be considered as natural preventive cure for COVID-19?
Naturally, I think I remember right from traditional days and in the villages, particularly in hometowns, I think many of them are now dependent on vitamin C in particular, right, which is a very powerful antioxidant, and that is said to be one of the important cure. And clinical trials were already registered. To my knowledge, I know that 7 clinical trials are already registered officially with vitamin C. So definitely, I think that is a wonderful booster for COVID-19 treatment.
Thank you, sir. Thank you for patiently answering all the queries. I thank all the speakers. Ma'am, Bhavani ma'am.
Yeah. Now,
Shall we call us?
yeah, you can. Yeah.
Now I request our secretary, sir, Mr. Kanakaraju, sir, to please share his views about the session. Naveen, sir.
I think his voice is in mute.
Sir is already in panel.
Once again, good evening, sir. Thank you, Ishwar. Thank you, Ramesh sir. Thank you, Kopula Sista sir. Thank you very much, sir. Yeah, sir. Thank you, everybody.
Yeah,
And you are
thank
giving
you.
good information regarding the repurposing of drugs, sir. It is very helpful to my students, not only my students, my staff, and all the over which we are giving the YouTube live, sir. Thank you very much for give a wonderful section, giving the experts full. Thank you very much, each and every person, sir. We will definitely in future also we will utilize all your services for the sake of development of pharmacy profession, sir. Thank you, sir. Thank you.
So thank you, Kanakaraj Garu. I think as rightly said by Shushu, we should not say from the bottom of the heart, but we wholeheartedly, right, again, it is the same. Thank you so much. And I think the credit goes to all your team effort. I think with a wonderful leader like Bhavani leading the team along with the various participants and the students involved, in particular Ramya, for having a lot of patience, because I think it has been a very long session. Actually, we planned to wind up at 4:45, but Shushu has taken a longer batting.
I think I have to compensate.
Teamwork, sir. Teamwork.
So thank you, Kanakaraj Garu.
Yeah.
I'm very happy.
Yeah.
Sir, you give wonderful sessions, sir.
Yeah.
Personally, I will interact with you, sir. It is not right time.
Yeah, yeah. Yeah,
It's
is there, Ramya, is anyone want to speak?
Yes, thank you, sir. I request the speakers, can you spare, if you can spare two more minutes? Our faculty would like to say the oath of thanks. Mrs. Krishnaveni, please. Mrs.
And I want
Krishnaveni.
you to take an group snap. I think it's an customary now that we should take a screenshot of this
Okay.
as a proof of concept.
Sure. Bhavani.
Yes, sir.
Yes, sir. Naveen, sir, is Krishnaveni ma'am available?
Yeah. Ask her to speak. Yeah.
Yes, ma'am, you can.
Yeah,
Yes.
it's audible. You can.
Good evening, everyone. Good evening, everyone. Myself, Krishnaveni. I thank all the speakers for their wonderful session on drug repurposing, especially Dr. Ishwar Kumar sir for their valuable information regarding the drug repurposing and also drug discovery and drug development and clinical trials, and also explaining about the drug different types of repurposing drugs in India, and also drug repositioning in India. Thank you, sir. Thank you for such an wonderful information, sir. And other eminent personality, Dr. Koppula Sushrita, sir. Sir, well explain about the need of repurposing drugs. Why you need the repurposing drugs, and also explaining about the drug repurposing is very useful in the future researchers and as well as drug development. And also, sir very well explaining about the neurodegenerative disorders. Thank you, sir. Thank you for wonderful information. And
My
also other eminent personality.
I think she went into mute.
The drug repurposing COVID-19 situation. Thank you, sir. Thank you for valuable information. I thank all the speakers. We have learned a lot through this session, sir. I thank the management of Koringa College for organizing such good session. I thank Sri Kanakaraju sir and Srimati Nagamani ma'am for supporting us. I heartfully thank Dr. Bhavani ma'am for taking efforts to bring all eminent personalities on the Arogya Rakshak Pharma Series 2 platform. Thank you, ma'am.
Thank you.
It helped us a lot. I express my gratitude to all the participants for making our session successful. I once again thank you our management for giving this such a wonderful opportunity to me. Thank you, sir. Thank you once again.
Thank you, sirs, for your gracious and fabulous session. It is our honor and grateful to have you all in a single platform. And I'm very grateful for your all support. I appreciate you and your passion for sharing the knowledge to all pharma professionals and buds in this pandemic situation.
And
I
I
value the
appreciate
insights
your
and guidance you have provided, especially on repurposing. I'm grateful very much grateful, sir. Sushruta, sir, in this session, whole thing, every student, those who are participated, everyone will remember this word, old wine in new bottles. Very wonderful, sir. Old wine in new bottles. Thank you so much, sir.
Remember the Legos concept, not the wine concept.
Thank you, sir. Thank you.
Maybe they will.
Thank you for spending almost 2.5 hours with us, sir. Thank you. Thank you.
Thank you so much, Bhavani, for continuously forcing us, pursuing us, and making it possible at a rural background. Wonderful.
Thank you, sir. Thank you very much.
Thank you.
Okay, sir. We can leave.